In problem 15, we want to find the probability of getting a pink marble followed by a blue marble if the marbles are drawn without replacement. So if they're drawn without replacement, that means that we're going to select one marble, not replace it back into the jar, and then select a second marble. So in this case, we want the probability of getting pink followed by blue. So what's the probability of getting pink? We're on the first draw. There's 3 pink marbles out of, let's see, 9 plus 5 plus 7 plus 3, so that's out of 24. Times, because this is an and problem. We want to get a pink and a blue in that particular order. So now, what is the probability of getting a blue? There are 7 blue, but now it's out of 23 marbles because we took one marble out and it's gone from the jar. So there's only 23 marbles left. But we always assumed that we were successful the first time. So we're assuming that there was a pink marble drawn the first time. So when we drew out the first marble, or I should say before we drew it, what did we have? We had 24 marbles, and 3 were pink, and 7 were blue, and then we had 14 others. Oops. Let me move this up a little bit. 14 others. Okay. So then what happened was we picked one out, and we're assuming that it was a pink. So now we're down to 23 marbles, 2 pink, 7 blue, 14 other. So that's why we have 7 out of 23 on the second draw. And when we do that, we've got, let's see, that's going to turn out to be 7 over 184? I think that's right. So 7 over 184 would be our final answer for that. And you can also get this answer by just typing into your calculator 3 divided by 24 times 7 divided by 23. And if you hit math and then enter and enter again, then it will give you the fraction in lowest terms, which is the easiest way to give your answer. Okay, let's take a look at 16. Now we want a pink followed by a pink, 2 marbles drawn with replacement. So we want the probability of pink followed by pink. These marbles are being drawn with replacement. So the first time, probability of pink is 3 over 24, just like in the last problem. So I take one out, I say, here's a pink marble, and I throw it back in. So now the probability of getting pink the second time is still 3 over 24. So the probability doesn't change because the marble has been replaced. And this gives us 1 over 64 in lowest terms. Now for number 17, it says a pink followed by a pink if the marbles are drawn without replacement. So what's the probability of getting pink followed by pink? I know that's a lot of P's. So we have probability here and then pink and pink. 2 marbles drawn without replacement. So 3 out of 24 the first time. Times. And now we picked out a pink marble. So we're down to 2 pinks out of 23. And this is going to equal 1 over 92. And if we look at 18, now here we want the probability of at least 1 green marble. And we're selecting 5 marbles without replacement. So the probability of at least 1 green marble. This is equal to 1 minus the probability of no greens at all. That would be the exact opposite. Getting at least one green means there's some green somewhere in there. Maybe they're all green. Maybe just one of them is green. But the opposite of that would be no greens at all, and that's a lot easier to calculate. So we'll do 1 minus the probability of no greens, and it gives us the same result. So this is going to be 1 minus. So what's the probability of no greens at all? We're drawing 5 marbles without replacement. So I'm going to make 5 blanks here for my probabilities. All right, what's the probability of getting not green the first time? So there's 24 marbles, and 9 of them are green to start off with, which means that there are 15 not green. So probability of getting not green the first time is 15 over 24 times. Probability of not green the second time, this is without replacement. So we took one out, and we're assuming that we're successful in getting not green. So the number of not greens is going to go down to 14. The number of total marbles goes down to 23. The number of greens stays the same. So the probability of not green the second time is 14 over 23. Probability of not green the third time, so that's going to be 13 over 22. And you can see the pattern. It's going to go down by 1 each time in both the numerator and the denominator. So that's 12 over 21, and finally 11 over 20. I like making the blanks, that way I know how far I have to go out. And when I multiply that all together, let me find out what that is. And that gives us 171 over 184. And that's our answer there. Now in number 19, we want the probability of at least one orange marble. And I don't know why that got thick all of a sudden. Okay. Let's try this. All right, probability of at least one orange. So this will equal 1 minus the probability of no orange. Same reasoning as the last problem. And to calculate this, we're going to say it's 1 minus, and then what's the probability of not orange the first time? So there are, let me sneak this down a little, oops, 5 orange marbles. Okay, so probability of getting orange the first, or not orange the first time, is going to be 19 over 24 times, and then the second time it'll be 19 over 24 times 19 over 24, and then times 19 over 24. And when we multiply this out on the calculator, it won't give you a fractional answer. I think the denominator is a little too large. So we get 0.607. Now, in order to enter this into the calculator, the easiest way to do it is to type in 1 minus, open parenthesis, 19 divided by 24, close, and then press the caret button. It's right above the division sign, and we're raising to the power of 4, and then enter, and that'll give you the 607, or 0.607. So that's how you would do those problems.